Good day, this is Professor Will, CBMD PhD. Today's Thursday, November 18, 2021. It is 3:02 and 46 seconds, AM Eastern Standard Time. Today's research, Microrobots. So let's hop to it here. The shape-morphing microrobots deliver drugs to cancer cells. Date November 17, 2021. Source, American Chemical Society. The chemotherapy successfully treats many forms of cancer, but the side effects can wreak havoc on the rest of the body. Delivering drugs directly to cancer cells can help reduce these unpleasant symptoms. Now, in a proof-of-concept study, researchers have made fish-shaped microrobots that are guided with magnets to study cancer cells, where a pH change triggers them to open their mouths and release their chemotherapy cargo. The scientists have previously made microscale, smaller than 100 micron robots that can manipulate tiny objects, but most can't change their shapes to perform complex tasks, such as releasing drugs. And some groups have made 4D printed objects, 3D printed devices that change shape in response to certain stimuli, but they typically perform only simple actions, and their motion can't be controlled remotely. In a step toward biomedical applications for these devices, researchers want to develop shape-morphing microrobots that can be guided by magnets to specific sites to deliver treatments. Because tumors exist in acidic microenvironments, the team decided to make the microrobots change shapes in response to lowered pH. The researchers 4D printed microrobots in the shape of a crab, butterfly, or fish, using a pH-responsive hydrogel. By adjusting the printing density at certain areas of the shape, such as the edges of the crab's claws or the butterfly wings, the team encoded pH-responsive shape morphing. And then they made the microrobots magnetic by placing them in a suspension of iron oxide nanoparticles. The researchers demonstrated various capabilities of the microrobots in several tests. For example, a fish-shaped microrobot had an adjustable mouth that opened and closed. The team showed that they could steer the fish through simulated blood vessels to reach cancer cells at a specific region of a petri dish. When they lowered the pH of the surrounding solution, the fish opened its mouth to release a chemotherapy drug, which killed nearby cells. Although this is a promising proof of concept, the microbots need to be made even smaller to navigate actual blood vessels, and a suitable imaging method needs to be identified to track their movements in the body. Good day, this is Professor Will, CBMD PhD, on microbiology, bioinformatics, and pathophysiology. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.